This video is brought to you by makeITsimpleTT, the premier online learning space for CSEC IT and computer science classes in the Caribbean. All our classes are run on the familiar and secure Google Classroom platform. The weekly videos are well laid out and labeled by topic, dated, and placed in reverse chronological order to ensure easy access even if you miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. Welcome! Flowcharts, right? So flowcharts are a way of you to gives you a way to represent an algorithm using symbols, right? So the definition is a flowchart is a diagrammatic representation of the solution to a problem. So when you want to solve a problem, you want to use either pseudocode or a flowchart. Pseudocode will be a type of code that will help people understand, or more than like they'll help programmers or somebody who's writing the code transition it from their words to the words of the programming language that you're using. But what makes it cool is that you can also do it in a diagram, and a diagram helps people understand. And when you draw a diagram for people, sometimes it makes them be like, oh my god, wow! And if you do that, your life may be a little easier. So let's go. The first set of symbols that you have would be a terminator. That was not me. Oh my goodness. Yeah, terminator. It indicates the beginning or end or start or stop. And the symbol that is used is an oval. The reason you use an oval is because that's what they say to use. If they tell you use an oval, use the oval. That's how you start and stop. Yeah, that's basically. So there was some point in time a child asked me, so why did they use an oval? I don't know why they use an oval. If it is, that is the set standard. So the standard is the standard. You're welcome. Right? So after that, the next symbol is called a rectangle, and this indicates the transformation of data. Transformation of data means that there is something that takes place when data is in this rectangle. Usually an equal sign is your kind of guide to let you know that. Right? The next thing would be the flow arrows. And the arrows flow from one symbol to another because it's a diagram. You are showing the diagram or something like that, right? Right, so the symbols would be input, output. That is a parallelogram. Now, a parallelogram has a particular shape. A parallelogram is when you take a rectangle and you kick it to the left or to the right. So it must lean. So you must clearly see that there is an angle being formed right here. That angle matters, right? Because if you make your parallelogram look too much like a rectangle, you'll get it wrong. So your parallelogram must actually lean. If it doesn't lean properly, then you have an issue. Then there is a diamond. A diamond is usually used for a decision to indicate a choice between two options, right? So let's go. Now, when you select something in a flowchart, you have two things that can happen. You can have if then, which will give you one choice. Hold on, I have to sneeze. Y'all were not supposed to hear that. Oh my goodness. You were not supposed to hear that, but that's okay. Right here. So, if then else, which we covered in video 3, I think, of this series. So go to video 3 and you'll understand everything about if then else, but this is the diagrammatic representation of it, right? Now, once you understand that, everything else is at your fingertips because you have the shapes that you could use and then you have the possible ways that it could go, right? I don't want your Panadol. Thanks. Alright, so let's go now to a simple example of a flowchart. Let's say we start and we ask somebody to input the age of a boy. You realize that the input age of a boy is in a parallelogram because we want to get something coming in. So if we were to write this as a program, the program would be start read age, right? Now the read age will coincide with this symbol here. And the reason it's a read is because we're using a parallelogram, okay? Now, the next thing is a diamond. A diamond will make a decision based on a condition. So let's say this condition is the boy younger than 5? There are two possible options that you could get from it. You could get a yes, the boy is younger than 5, or you could get a no, the boy is not younger than 5. If the answer is yes, then in this case, you tell them they have to come back. If the answer is no, you tell them they have to, they could come in school. So if the boy is younger than 5, yes, you are too young, therefore you have to come back next year. No, you're not younger than 5 here, therefore we can accept you in school. And great. And then both of them will meet the output part of stop. Notice all of the shapes match their corresponding words. So you see input age, or input command, definitely that. Accept them in school is an output, that is an output. This is a decision. Anytime you have a question, tell yourself you have to put it in a diamond. Anytime you have a input or output, it's a parallelogram. I haven't shown any processes as yet, but we'll get to that just now. So this is a simple example using real life things, right? So normally how I teach is I kind of give you a little real life understanding of it first, and then I'll show you how it actually translates to the schoolwork. So we'll get to the schoolwork part of stuff. Right? Nice. So look at next real life example. Leave home. Found this one somewhere on the internet, right? Leave home is our start because that's where you start the process of leaving home. Check the time. Checking the time is an input because you are getting the input of the time. So you read the time coming in. Then you have, is it before 7 a.m.? The answer is yes or no. You can have either one of them too. But remember, this is a question. Because it's a question, it has to be a diamond. A diamond will clearly give you two choices, yes or no, coming out of it. Right? If the answer is yes, you have to take the bus or you have to take the subway. The reason these two are in rectangles is because they are processes. The process of taking the bus or the process of taking the subway. You're not telling them to take the bus or take the subway. It is a process. So anytime something is going to be done, right, or carried out, you put it inside a rectangle. That's how processes work. And then the end will be reaching school. So all the symbols here will always line up to what they are trying to do. And that's the whole point. This here is determined what transport you take depending on what time it is. And those are two basic real life examples. Now that you have gone through the real life examples, let's see how we could do it by changing pseudocode to a flowchart, because we would have learned pseudocode in videos 2, 3, 4, 5, and 6. Right? We learned all the pseudocodes from selection, from sequencing to selection to loops to mixed control structures to the Dr. Strange question. Right? Check all the previous videos on this and you'll see, because remember, this video is part 7, by the way. Part 7. I've been teaching the whole of pseudocode and algorithms from video 1 all the way up to now. But they're not long. They're about half an hour each, right? So in about, I don't know, 3 hours you'll be able to learn the whole algorithm. As I was saying, yeah. So now, let's see how pseudocode could naturally translate to a flowchart by just looking at the keywords. And once you look at the keywords, you know the shape. Once you know the shape, you put the words inside the shape and you draw arrows to join them, and you are a winner. So let's try this one. Pseudocode with start. What type of shape should start be in? Well, we'll figure out. Read N1, N2, and N3. That's number 1, number 2, and number 3. What shape should that be in? Calculate average N1, N2, N3 divided by 3. What shape should that be in? We'll figure that out. Write average and stop. So let's go. Think about it. Start is a oval. Read, number 1, number 2, and number 3. The keyword is read. Now that I know I'm reading, I have to use a parallelogram. Make sure the parallelogram is leaning, because sometimes your parallelograms look something like this. And we don't know if it's a rectangle or a parallelogram. Once an examiner sees this, they'll be like, nope, child doesn't know what's a parallelogram. Make sure your parallelogram leaning, and it's clear that it is leaning, because I guarantee you, you will lose the marks. You don't want to lose those marks. Hold on, I need a sneeze break again. Right, yeah, I am back. Good. Now, look at the next thing that happens. Average is equal to N1 plus N2 plus N3 divided by 3. Because you are calculating something, you have to use a rectangle. But watch closely. The key or the trick to basic flowcharts when it comes to rectangles is look for equal sign. If you see an equal sign, 99% of the times that equal sign means there's a process taking place, and you're going to put that in a rectangle. So the moment you say equal sign, rectangle fit one time. Don't even ask a question. You ain't gonna see anything else other than that. And then right average is our output. So our output is going to be a parallelogram, because inputs and outputs go in parallelogram. And then stop is oval, because that's the rules. That's what they said. They gave us the 4 shapes. They gave us the arrows. That's how you draw a flowchart. So this is the question. Start, oval. Read, parallelogram. Calculate, rectangle. Write, parallelogram. Stop, oval. It literally comes out like this, and you're good to go. Hold on. You weren't supposed to hear that either, but that's okay. Right, so my sinus is fighting. So let's try to do 3 questions that will help you understand flowcharts. Now, in order to understand flowcharts, you have to do them. Like all things in life, you have to do actual work to learn stuff. Like the work to really go in your head and stay there, because yeah, it doesn't work like that. So let's try 3 questions, right? Draw a flowchart to represent the sum of that accepts 5 numbers and find their sum. So let's go. Okay, wait, hold on. I'll do the hardest one. I'll do number 3, because we don't have time to do all 3 of them, but you can try them if you want on your own time. Draw a flowchart that accepts 5 numbers, so we have to get 5 numbers, finds their average, and if the average is bigger than 49, display you've passed or display you have failed. So here's how we'll do this. Let's write out the algorithm fit first, because this is the easier way to do this. So write out the algorithm, and then after you write out the algorithm, you could draw the flowchart. So we want to put a start, C-A-R-T. I know how to spell, trust me. Start. And we want to read 3 numbers. Read, I'll put in A, B, and C for now. A, B, and C. And then I'll say sum is equal to A plus B plus C. And then I'll say average is equal to sum divided by 3. Yes, I know you can do the average by just adding up the 3 numbers and dividing them by 3 one time. But I'm purposefully doing like this because I want you to see the different shapes. This helps you understand how the shapes are supposed to go, right? Then I want to say if average is greater than 50 or 49, then print pass, else print fail, end it, and then stop. So that's a basic algorithm. In video 3 or 4, we would have gone through algorithms like these. So if you don't understand how this works, then just go back and check one of the previous videos. Now we're going to translate this to a what do you call this thing? We're going to translate this to a flowchart. So start is definitely going to be an oval. So we put the oval for start. I'm going to try to line up the symbols as close as possible to where the line is, right? Read A, B, and C will be a parallelogram. Read A, B, C. After I read A, B, and C, I want to now find the sum of A, B, and C. So sum equal A plus B plus C. And then I want to find the average, which should be a rectangle again. Should be average is equal to sum divided by 3. Right, notice once there's an equal sign, I'm putting it in a rectangle, right? No questions asked. Now, once I reach the if, I have to do a diamond. So what's the diamond here? Diamond. And the diamond is going to be if average is greater than 49. Put a question mark because it will help you understand that you have to do a yes or no, right? Now, yeah, yes or you know, you could put them one after the one on each side. So let's say the answer is yes. What will be printed out if the answer is yes? The answer that we printed out is print pass. So we put the parallelogram and we put it pass. And then on the other side now, where the answer could be no, we would put print fail. And then both of them now would converge. Big word there. Converge on. Ta-da! How do you feel about that? That is a solution or solution. So I want to blow my nose again. So I'm going to give you all of me.
Total concentration. Water breathing. The 11th form. Dead calm.
That was an actual rendition of what went on in my nose at that point in time. Let's check. Go on, right. So that's the answer for this. Right, so this simple question here, I did number 3 because 1 and 2 too easy, right? And so look at you learning there already. Now, how do we represent these flowcharts with a loop now? A loop is a little more technical. Hold on, just turn on charge. That is totally me not sneezing there unnecessarily. I guarantee you I don't have coke. Yeah, this charger now. Okay. Oh, look at the bouquet now. Hold on, need to sneeze. Alright, I promise you're good now. Ish, kinda. Right, now, let's see how you do a loop in a flowchart. Now, to represent a loop in a flowchart, you have to be able to make the decision, and you have to show how the decision goes back to check on itself. So a loop is basically a condition that checks on itself each time. And as long as the condition is not true, it will just keep going on. I mean, not false, it will just keep looping over and over and over and over. So a flowchart is really a good way for you to understand loops a little better because you can see how the decision making flows, right? So there you go. Let's look at the repeat until. Who's this doing here? So I really did a righty button, so you did a right thing. Hey, nice to see you, right? Keep on the channel, you'll see text stuff, right? Calm your nose down. My nose is not behaving. Okay. So repeat until. Repeat until is going to say, okay, read age until age is greater than 18 and display age. So if we were to try to translate this, we would be, okay, repeat the process of read the age. Read any age, because it's a read, it's an input statement, we want to put a parallelogram to read. And then it has to check if until age is greater than 18. If age is greater than 18, this is a definite decision. Age greater than 18, it could be yes or no. As long as the age is not greater than 18, you're going to see this thing loop back up here. This now says, no, the age is not greater than 18, therefore, repeat. So this is the easiest way to see that the decision, this box right here, is the one that makes a decision and says either yes or no. But if the answer is no for the repeat until, it's going to go back up to read the age over. And here's where you create the loop. So you can see the loop going like this. Looping, no. And then as soon as I hear yes, it'll be like yes. And then it goes down and it's like display age. And it displays the age, that'll be the representation of it. So if you have a repeat until, it's usually one of the easier ones to represent with a flowchart. That's why I started off with this one. But pretty straightforward. So let's go again. Now, here is one of the most important parts of a flowchart. You cannot represent a for loop in a flowchart by itself, the way it is. You can't translate it line for line. You cannot represent a for loop in a flowchart like that. So you can't say, hold on, right. So you can't say in a flowchart, you can't put a diamond and put any diamond 4C is equal to 1, 2, 10. That is not possible. The flowchart doesn't accept that because a diamond is only allowed to accept one thing. It can't accept that. It could only say C less than 10. Meaning a diamond could only ask very basic questions. This video is brought to you by makeITsimpleTT. Our CAPE classes run on an 8-month cycle and covers everything in the CAPE IT and computer science syllabus with 10 years of past paper practice included. Students get assignments topically and reports are emailed to parents and guardians monthly or bi-monthly. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. A diamond can't do a complex thing as a for loop. So you have to figure out, how do I get my for loop to do the correct thing? And it goes like this, right? So this loop here, 4C is 1 to 5, is the same thing as set C as 1 at the start, say where C is going to stop, and then carry up C by 1. Hold on. Right? I promise you I'm okay. Yeah, right. So a for loop goes from 1 to 5. Now I could make the for loop go from 1 to 5 easily. That's not a problem. But when it comes to representing it in a flowchart, I must make sure that the flowchart has to be converted, the algorithm, has to be converted to a while loop or a repeat until loop, one of the two, because the for loop is not going to be able to be represented in the flowchart. In order to do that, I must convert it by taking C is equal to 1, then take C is less than or equal to 5, and then C is equal to C plus 1. Those are the three things that I need to make sure that this for loop will be represented as a while. Once you convert it, everything is easy after that. So now you could say I have C is equal to 1. That's that box there. Why is the rectangle? Because there's an equal sign. A process is taking place. Once there's an equal sign, tell yourself there is a process, right? C is less than or equal to 5. That is there because that's a choice. It's a decision. Therefore, it goes in a diamond. So is C less than or equal to 5? Question mark. The answer could be yes or no. If the answer is yes, that means the number is less than or equal to 5. Then I want to read a new number. So I read the new number there. And I say sum is equal to sum plus num. Why do I put that in a rectangle? Because there's an equal sign. I'm doing some calculation, so that's a rectangle. And then I have to carry up C by 1. The reason I'm carrying up C by 1 is because it's supposed to be a counter. If you don't understand why there's a counter, check video number 4 or 5. I can't remember which one it is. Now, this is going to loop back all the way up to the start of the while loop. The start of the while loop asks the question, is C less than or equal to 5? And the answer to this question will determine where the flowchart will go. So the answer could be yes, and it will do the whole loop again, or the answer could be no, and it will not do the loop again, and then it will skip whatever the loop said to do, which is this whole block here. Once the condition says no, it's not true, it do the last thing, which is print sum. That's it right there. That is the key to how to represent a flowchart using a loop. A repeat until loop is easy to do. A while loop is easy to do. You can't do a for loop, so you have to know how to convert a for loop to a while loop to be able to get it to be represented in a flowchart. And that is power. That is power. Let me escape it. So let's go through another question just to make sure you're clear and you understand. So this one says, please enter the numbers you want to add, which is the start. So you can see that that is going to be a parallelogram because it's a write command, meaning it's an output command. Anything that has an output command must be in a parallelogram. Get number, that's an input command. So you're using the same parallelogram again. Now when you have an input command and an output command, you have to put them in separate parallelograms. But if you have two output commands, you can put them in one parallelogram. If you have two inputs, you can put them in one. But don't mix them up, right? Separate them for your sake. This one says while number is not equal to 0. So while number is not equal to 0. Yes or no. It could be one of the two because remember, it's a condition. So we're asking, is it a yes or is it a no? Is it a yes or is it a no? And then you realize, okay, cool. So the number is equal to 0. You'd say, no, it's not. So therefore, I'm going to go through the process of total is equal to total plus num. Right? Please enter second number. And then I have to get the number. All of these three commands, command number 1 is for there. This is an input, and that's an output. And this here is a output. So now that's going to loop me all the way back up here. And when I loop all the way back up there, I'm like, yes, I know how this thing works. And then we check the condition again. Is the number that they put in, where's the get number here, is that equal to 0? The answer is no or yes. If it is yes, then you print the total. So most of the time, the questions will give you, if it's a loop, they will give you the flowchart. They'll give you the pseudocode and they'll ask you to draw a flowchart. Once you get that, then you're made, because all you have to do is match the type of input or output and make sure you take note of the condition and you should be okay. If you have to come up with the answer and then draw the flowchart, that might be a little tough, but all is smart. Hold on 1 second, I'll be back. Right, so that is how a flowchart will be represented. So let me try to do a simple flowchart here, which is find the largest of a series of numbers that terminates when the user types 0, right? So let's see if we can make sense of this. In order to find the largest of a series of numbers and terminates when the user types 0 is the exact question I did in video number 5 or video number 6. I think it would be video number 5 or 6, one of the two. When we start to do loops, so we did max and min, video 5 or 6, because this video 7, somewhere around, it should be 5. So the actual algorithm will be start, max equals 0, num equals 0, print, enter, number, and 0 to start. And then I read the number, and I say if num is equal to 0, then what will happen? If it's equal to 0, then I will, the answer is, okay, sorry, I'm gonna do it this way. If the number is not equal to 0, what do I want to do? I want to say if num is greater than max, then max is equal to num. And then this one is also, this will say while number is not equal to 0, right? So, and then now, end while. And once the while is done, now I'll print the max. Right, so I worked on this question some time ago. If you want the full explanation of how this question works, yeah, go back to the previous video. But what you will see is once you get the pseudocode done, you can see that there's a direct match to the shape. Start is over, max equal to 0, and number is equal to 0. Equal signs again, being processed. Print enter 0 2 thing. So that will go to that. Read the number, parallelogram, because it's an input. While number is not equal to 0, we will be able to check here. Now, one of the things you'll notice is that when you do the flowchart, you might want to ask the question, is the number not equal to 0 or is the number equal to 0? If your brain works in a way where you can be like, okay, while the number is not equal to 0 and you just put it inside the diamond and you make the choice, cool. If, however, your brain could do the opposite, which is number not equal to 0 and you check for equal to 0 in the flowchart, just make sure the yes and no's match to where it's supposed to go. Everybody's brain, I've realized, works differently when it comes to this. So some people like to put the opposite, some people like to put it straight. But let's make sure you know why the yes and no goes in each direction. As a key. So number is equal to 0. The answer is no. Then what we want to do is check to see if the number is greater than max. So because if the number is greater than max has to be a decision, because it's a if the number is greater than max, then you know, okay, cool. If the number is greater than max, then yes. So for the yes part now, you have max is equal to num. That is a rectangle because there is an equal sign. There is no else statement, so the no will just match back up. And you see this line here, that looping back up, this is your key. You must be able to loop back up, and that's what the end while really tells you to do. The end while basically says, okay, now go back up the road and check to see if the condition is still true. If it goes back up the road and I check to see if the condition is still true, that is what this line here symbolizes. Check to see if it's still true. And if it is not, then your end while will be like, okay, cool, we are done. So what comes next, which is print max, and then stop this stuff. So being able to translate a flowchart like this is easy marks. I'm talking about cake, because all you're really doing is matching symbols or shapes to words. And as I said, most of the time, the questions that they give you, they always give you the algorithm or the pseudocode, and they want you to draw the flowchart for it, and you can just match it up. It's like taking blocks and put them next to each other and be like, this is a read statement, this is a parallelogram, this is a decision statement, this is a diamond. The only technical thing is really when you have the while loop and you have to go back up to where the decision is being taken. When you could go back up to where the decision is being taken, that's when you really have the skill of understanding how the arrows make a difference. So that's it for flowcharts, and the next video that I should be doing would be trace tables and truth tables, and that'll be the end of the algorithm series. Oh, nice. Yeah. This video is brought to you by makeITsimpleTT. Every class is structured to run on a yearly cycle from June to May. This cycle covers the whole syllabus in 12 months with 1 2-hour session per week, along with assignments that are given weekly. Every class is recorded so students can always go over the work and recap notes in case they miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799.